also allows us better gating for infrastructure changes. Something will blow up completely isolated in dev, and that's what we want. And the centralized logins obviously reduces quite a bit of risk. All right, so I'll talk a little bit about about HIPAA as it pertains to actual AWS services. So the basics is you actually have to go to Amazon's website, and I think it's actually aws.amazon.com/compliance. You go there and you fill out a request form. You can put in your phone number and email, but I don't think they use the email because they tried to call me. So I ended up delegating that to someone else. So the second thing is you have to actually use specific services. So they have a white paper that defines which specific services that you can actually use and how you use them. So this is the full list of the services that you can use in AWS to actually process any PHI data. You'll notice RDS is specific for certain engines. So we can't store any PHI in Postgres RDS, for example. And also DynamoDB, the last on the list, you actually have to utilize KMS if you're going to put anything containing PHI data. So you have to encrypt it before you put it in DynamoDB. The rest of the services support encryption in some way or other. So a little overview. KMS is Amazon's key management service. How many of you actually used KMS at all? All right. That's quite nice. It allows you to create master keys that are stored with AWS. We never directly retrieve them or have any kind of access to it. And if you want to use your own keys and stuff, it also supports using the hardware modules. So you can actually import your own keys and if you need to. We don't do that. So it gives you a key, and then it basically gives you an API for encrypt and decrypt, and a couple other API actions that allow you to work with the data. So services that actually support KMS built in, they call KMS from service accounts. Redshift, for example, comes from its own IAM account. The second thing is you have to enable logging for all the services that support it. Logging tends to go to S3 for anything that supports it. So Redshift, you turn on logging and it goes to S3. S3 logging goes to another S3 bucket. Different services structure their logs differently. S3, for example, looks a bit like syslog. So anytime someone accesses an S3 bucket, you get a line output and it gets delivered to S3. CloudTrail logging, this is what tracks API calls. Specifically, it tracks create, modify, and delete API calls. So anytime any of those things get touched, you get a log entry that tells you what account it came from, what user, what role they might have been using, and what resources they actually modified. CloudTrail logs are actually structured JSON logs. And the other thing is to use IAM roles everywhere you can. IAM roles, for those of you who don't know, are awesome. They allow you not to have a access key and secret key. So every time you use these roles, you actually have to assume a role. And when you do this, you acquire temporary scoped credentials from Amazon Security Token Service. And these have various timeouts. Like by default, when you assume a role, it's 1 hour. And also, every time you assume a role, CloudTrail logs it. So the basic, we're able to give our admins and our devs really limited credentials, and when they want to elevate those credentials, they assume a role. And this is supported by the AWS command line, the console. So I actually log into the main account, and I'll switch over to the dev account, back and forth. It's a lot funner than logging in and out of accounts and opening incognito browsers. So a little bit about the pipeline that we've actually built. This is how data gets from our client to end users. And typically these end users are downstream from our client. So like we sell to our client, and then our client sells their apps downstream to other clients. This is the basic rule and where you want to get to with everything. You don't want to have to touch anything. So what we've done to allow secure uploads to us is the first principle is clients do not have an AWS account. We don't give them any credentials or any keys. They actually have a username on our platform. This actually just uses Django authentication right now on the back end. So hey, they have this account with a password. We'll send them invites and they can access it. So we have a command line app that they can install. It's pip installable. And this allows them to log in to the API, and this will give them a scoped S3 policy that allows temporary upload access to a specific randomized prefix in S3. We further scoped this down to client-specific prefixes. So when a user logs in with the command line, it actually uses netrc for authentication. This is the same thing used by the Heroku command line and a lot of other applications. But that gives them an API token. And so once they get this, the data is actually uploaded directly from the client's machine to S3. So we never touch it. And the main reason for that is because if we actually allow the upload to our service in some way via the API or via a web interface, we would actually have to carry a lot more risk by acting as a file proxy. This has a lot of other logging and access rules around it that we want to avoid. So the file goes directly from the client to S3. So from that point, it's in a randomized location. First of all, I should mention on the ETL front of this, we are not 100% there yet. We still don't have all the automation pieces done. We have a very good idea of where we need to go, and we're about a week and a half out from finishing this up. But we have some things that move the files from this randomized location into a place that our ETL jobs can pick them up. And we run these ETL jobs. For PHI-based apps, we have to run these ETL jobs on EC2 instances, not on ECS because it's not approved. So we've developed internally a Luigi-based ETL library. For those of you, anyone here familiar with Luigi? It's a library from Spotify. It's basically helps to determine task order and execution. So you give it a list of tasks that need to run. It checks to see if they need to run and determines order and makes sure things aren't running at the same time when they shouldn't. So we've built something around this a little bit, abstracted it some. Yeah, from that point on, we want to get to an event-driven type model. So a user uploads the data, we fire off an event to our service, and then we have other services that pick up, move the files, and load the data in. These are pretty basic loads. When it comes to Redshift, loading data into Redshift, you either have a CSV file or a JSON file in S3, and you issue a copy from command, and so it just copies it straight into the Redshift tables. So at that point, it's actually in Redshift, and Redshift's an approved service because it has encryption and it has all the logging. So the logging actually Redshift has is there's a user log and a connection log, and those are the main things you need for HIPAA compliance, and you have to enable this when you create a new cluster. The user log logs any creation or modification of a user or group, anything that might affect access rules to any PHI data. And it also has a connection log, which logs every connect for a query and where it's connecting from, that kind of thing. So once we got it in Redshift, we're pretty happy. And now our application, which is Django-based, and we're running it on EC2. So the main thing you have to have for EC2 is what's called dedicated tenancy. This is why people don't run PHI compliant apps from home or for personal use, because the dedicated tenancy is a $2 an hour charge on top of any server costs. So you're looking at $1,400, $1,500 a month. And dedicated tenancy means that it's actually running on dedicated physical hardware from Amazon. So no other applications should ever interfere. And they require that for anything that processes PHI. So our application itself, I mentioned we use Django authentication for the back end. We had to implement password policies, and that means complexity and also rotation policies. And the third thing is we have to actually log still, just like any access to PHI, we have to log the access to that. So when they load the app, any access to an app that contains any PHI data is required to be logged. So we log the user, the IP, and what they're looking at when they looked at it, and that kind of thing. And we also do a browser session expiration. So if a user walks away from their computer, we can expire the session on the front end, so people don't scroll through the data in the browser. All right. So a little bit about the difficulties that we've had doing this and where we've struggled. So I've learned so much about IAM in this past 3 months, and even more before that. But IAM is deeply powerful and complex, and I've come to love it. I don't know if I hate it much, maybe a little bit, but I love it. We've also had to learn, since we're using multiple accounts, we've had to learn how cross-account policies work, and we've had to learn how all the roles work. And this varies. You have login from devs, sysadmins, and that kind of thing. But different services like Redshift can assume roles. You could have Lambda assume roles. You can have ECS tasks and services.